is important for us to read that article, Lancet article, in a little more in detail to understand what are the sources of pollution in the air. Okay. So, you have to get that big picture first and then look at the fact that what is it you want to go after, so that you will reap rich benefits if you control one of those variables, right. So, you must read that article very carefully. We cannot cover the full article, but I will give you an overview of this article which I already started. So, let me point out to this article again, which essentially says India, as far as India is concerned, highest annual average ambient particulate matter 2.5 exposure levels is the highest. This is the highest, we are the highest in the world. Okay. This is a big highlight, we are the highest annual average ambient 2.5 exposure levels. That means each humans, it is basically based on the annual population weighted ambient mean for PM 2.5. This, if you take this way of calculation, you understand that we are the ones who are exposed to the maximum levels of PM 2.5. WHO recommendations, World Health Organization recommendation is just 10 microgram per meter cube based on the same metric, annual population weighted ambient mean particulate matter 2.5. But Indian standard is not saying that. Indian standard comes from National Ambient Air Quality Standards of India. I have written it here, and this essentially is the one that is laying the standard. And 77% of India's population is exposed to even the National Ambient Air Quality Standards of India, which fixes at 40 micrograms per meter cube. So, 77% of India is even greater than the value that is fixed by the, even by Indian standards, the value is very high. Okay. So, 77% of India's population is exposed to greater than the National Ambient Air Quality Standard, which is really an issue. I mean, it is such a serious issue that you have to somehow see how can IoT solve, not solve, I would say at least as a first step to monitor the air quality standards in this country, a large scale monitoring, large scale monitoring, cheap sensors. Okay. Cheap sensors, any R&D lab which sort of puts maximum effort in trying to design, develop and make air quality sensors, I think will do a great service to this country by reducing, cutting down, by making things very cheap for sensing and monitoring of air quality. Once you know that there is an impending danger somewhere, you can do 100 different things, but first step is to actually start monitoring and give you a real feel for the spatial distribution of the air quality in a city, in a village, in any urban setting, rural setting, industrial setting and all that. So, this is important. So, you must look at sources of particulate matter. So, this article, while it is talking about particulate matter, what shall I say, in a way that it seems to make noise just about particulate matter, this is really not the truth. There are other elements also which are essentially causes for human suffering from air quality deaths. However, particulate matter indeed is a big contributor. Percentage of people dying due to particulate matter is a particulate 2.5 is indeed a large number. So, it is not that it is a biased opinion about just particulate matter and what happens to other air pollutants. This paper is sort of focusing more on the PM, because that appears to be the one that seems to have a maximum impact. For example, it encompasses several areas from which you can look at air quality. I will come to that, because this article itself is talking about that several areas in which PM actually gets generated. The first thing is solid fuels is an important thing. Why is this critical? Because you look at different type of efforts by several national labs and institutions, R&D labs and all that. They come out with what is a good stove for the village population, how to ensure that they do not absorb too much of smoke and which is encompassed with so much of particulate matter, because you need to cook, right, and there is no fuel. This is the fuel essentially. Solid fuels are essentially fuels for cooking, and this is a source, huge source of air pollution in households. See, if your problem starts right inside your home, even for a country like India it is going to be very hard to cut down, because you can't monitor at the household level what you can do. Therefore, major initiatives have to be taken to dispel this problem of air pollution in the country itself, and therefore lot of effort has gone in trying to make fuel efficient, clean energy based stoves for cooking stoves for village, for towns, for cities and so on. So, the effort has been there. So, you make it cheap, make it affordable, let people buy that and make the necessary fuel available and create an ecosystem around the availability of fuel, clean fuel, then people will start using it and cut down on usage of all the solid fuels, which essentially can be the major source. So, it is decreasing, there is no doubt about it. In this country the usage of solid fuels is coming down, but we need to do a lot more, that is the point really. So, still 56% of India's population is exposed to household air pollution. This is indeed the major problem. I often go back in many years in time to let us say 40 years back, right. So, to own a wristwatch for every individual in the house was not really a reality, and there used to be one wristwatch and one clock in the house, and that clock in the house was a big luxury, right, which means wristwatches were very expensive, you can't afford it. But today everyone has maybe I do not know tens and 15s of watches, each time you go you buy a new model, you want to own it, it has become cheap, affordable. So, if you can get air pollution measurement to simple devices like this, and you say that wherever you go you get a beep or a buzz and say that this is polluted here, and it is just 10 rupees I can buy, 15 rupees I can buy a watch of that nature, although it has just a lifetime of about a month or two. I will use it, I will ensure it is biodegradable, I will throw it, I will buy a new one and then I will be done. Fantastic, right. So, you are really revolutionizing the way you are doing air quality measurement. Every individual around wherever he or she is making a measurement and sort of getting some update on what is good, what is bad and so on. But that is really a dream, it is not going to happen just like that. At least at the household level, if you have a piece of equipment which sort of monitors everything, it is like the wall clock. Okay, if you have one wall clock equivalent thing for the home and it becomes affordable to buy that device, fantastic, you have done really wonders. So, let us see how to build these systems and what kind of problems technologists have in trying to instrument and make these systems cheap, affordable as well as system design such products. So, this is one thing. So, summary is you must go back and read this article. So, I will open this article for you, and this is the article of interest, reading this article, and let me ensure that we go through this article in a little bit more detail. I have marked some parts of it, I am sure you will be able to download this article and read it and look at how grim the situation is. So, this paper is also talking about how does one arrive at some super conclusions like the ones that we have. This paper is talking about the methodology as well. So, it will give you some idea on how they went about making that research and how they actually concluded. So, the methods in which they have used to estimate air exposure of air pollution, what is the area, what is the grid size and what kind of methodology they adapted, all of that is out there in this paper. So, we will skip all that, but we will come to the most important part, which is sources, right. You can see here this particular part, it says of the total population in India in 2017, 42.6% of residents were exposed to mean particulate matter 2.5 greater than 80 microgram per meter cube, and 76.8% were exposed to mean particulate matter greater than 40 microgram per meter cube, which is the limit recommended by National Ambient Air Quality Standards in India. This is indeed the Indian standard. Then it says across states what is the exposure and so on and so forth, and the number of deaths that are attributable to ambient PM pollution in India is 2017 was some number 0.67 million, and the number attributable to household air pollution is 0.48 million. So these numbers will keep coming and you have to read it carefully to understand what exactly is the real issue behind this air quality. Okay, so just to fly through this article. So let us do this reading together and get a grip of the subject. Control of ambient particulate matter pollution requires several action in several sectors and linkage of these actions for greatest impact, exactly what we discussed. Several studies have estimated the contribution of various sources of particulate matter pollution in different parts of India, which can be useful in informing efforts that are needed to address these sources. Several government initiatives have been launched in the past few years to reduce air pollution. Okay, several efforts have been there, and this include reduction in PM emissions by coal power plants and reduction in energy consumption by energy intensive industries. So first thing, reduction in PM means you should do reduction in particulate matter emissions by coal power plants. Our coal power plants should be much more efficient in its generation, and also it should have efficiency in reduction in PM emissions. This is what Ministry of Power is pushing. Setting emission standards for the brick manufacturing industry and facilitating management of agricultural residues to reduce stubble burning. This is become a major issue. In fact, the problem of Delhi pollution, air quality pollution indeed is something happening from neighboring states, at least this is what the claim of the Delhi government. So this is the second thing, facilitating management of agricultural residues to reduce stubble burning. So one is coal power plants, second is stubble burning, Ministry of Environment, stricter vehicle emissions regulation and upgrading of vehicles to more fuel efficient standards, third is vehicular pollution, right, and that is from Ministry of Road Transport and Highways and Ministry of Petroleum and Natural Gas, and the other one is an enhancing availability of public transport. When you do mass transport of people, you are bound to reduce the number of fossil fuel driven vehicles, and therefore public transport, Ministry of Urban Development and so on. Mechanisms that help reduce air pollution should be included in the Smart Cities mission launched by Government of India. About 2/3 of electricity in India is produced from fossil fuels, mainly coal. See, it is again back to coal, but India has pledged in the Paris Climate Agreement to generate 40% of its electricity from renewable sources by some year 2030. State specific policies such as compressed natural gas by vehicles in Delhi, subsidies for alternative technologies to compost agricultural waste instead of burning it in Punjab, and mandatory use of fly ash in the construction industry within 100 km from coal or lignite thermal plants in Maharashtra could be expanded to other states to efficiently control particulate matter emissions. So there are mitigation mechanisms which are looking at how to manage particulate matter generation itself, so that you have clean air. Another initiative is the Clean Air for Delhi campaign launched in early 2018, which subsequently to launch National Clean Air Program that aims to sensitize public and enhance coordination between implementing agencies for control of air pollution and so on, right. So then there is other initiatives such as intended nationally determined contributions targets to reduce PM emissions by 33 to 35% by 2030, promotion of electric public transport fleets, upgrading vehicles to Bharat stage 6 which is equivalent to Euro 6 standard. Vehicle emission standards are also encouraging, but will take some time before any substantial effect is seen. So, you can see so many reasons why particulate matter is an issue. Coal fired, right, coal is an issue, then stubble burning is another issue, then vehicular emissions is an issue for generation of particulate matter and all that. So, the fourth one indeed also we will come to. So, we have already identified 3, right. The very high ambient particulate matter pollution levels in North India in the winter season result in attention to this matter by the media and public, with discussion on focusing on the acute health problems due to high pollution, whereas the much more important longer term adverse health effects of chronically high pollution levels throughout the year have yet to be fully realized. More awareness needs to be created about the slow but substantial impact of ambient particulate matter and household air pollution among policy makers and the general public, which would help further enhance the air pollution control efforts in India. So, you can see household air pollution is another major problem. So, how many have we identified already? Coal fired power plants, stubble burning, third one is vehicular emissions, fourth one is household air pollution. Four major bullets, if you have to say what generates particulate matter, you can think of these 4 as a major problem, and you have to control each one of them as much as possible, and you have to monitor first. If you have to control, you have to monitor, right. So, you have to do sensing. So, the large scale sensing, then followed by some actuation, some control. Come to household air pollution. Government initiatives to reduce solid fuel use tackling household air pollution include a major scheme. You know about the Pradhan Mantri Ujjwala Yojana, which was started in 2016. It is trying to provide clean and safe cooking fuel, liquefied petroleum gas to about 50 million low income households by some year, by adding 10,000 more distributors and trying to giving access clean fuel, and so essentially all of this means that you have to move in the direction of sense and mitigate, reduce particulate matter, right. The WHO air quality standard within homes is there, and you have to adhere to those WHO recommendations, so that you essentially keep the pollution levels at the manageable levels. There are several studies that reports residential biomass use related emissions to be one of the largest contributors of population weighted ambient PM 2.5 concentrations. So, in densely populated communities, it has also been shown that health relevant reductions in household air pollution are best accomplished when entire communities transition to clean fuel. It is not enough if you do in one. So, you have to do it in a major way. Smokeless villages, in all that you have to worry about. So, essentially I want you to read this paper in great detail and arrive at your own conclusion on why this is a huge problem and what we can do to reduce, to monitor using IoT sensors, and ensure that you move towards a positive momentum which could be boosted further by state specific evidence presented in this report to enhance the planning and implementation of air pollution control efforts across India in a sustainable manner. This is important. It is important to note that besides benefiting human health, the reduction of air pollution in India would also have a broader beneficial impact on other aspects of ecosystem, including animal and plant health. So, you can see that this is a major problem, and so let us summarize the whole areas under which we could put sources of PM. Solid fuels, Pradhan Mantri Yojana is there, all that you have seen in those articles. Second one, stubble burning, right. This is agricultural residue. Third, transportation, right. This is all about vehicle emissions. Okay. So, solid fuels, stubble burning, transportation and energy sector, energy generation sector. Generation, coal fired plants for the purpose of energy. I would say that you should replace, and then you say solid fuels. How can IoT solve this problem? Okay. This is the issue. What I suggest for the remaining part in this course, rather in this module, ultimately we have to build systems, right. Let us look at ambient air quality and also let us look at vehicle emissions. So, I mentioned to you about ambient air quality. So, okay, I will put back this chart for you. You can read some numbers. You can see ambient air quality, these are important. There are others, okay. There is sulfur dioxide for instance which is missing in this, but nevertheless nitrogen dioxide is the range here, is the number here you can see. Nitric oxide is mentioned, ozone is mentioned, NH3 ammonia is mentioned, then hydrocarbon is mentioned, particulate matter 2.5 is concerned, and particulate matter 10 is mentioned. You can see that 40 microgram per meter cube is what the safe value which is proposed by Indian standard, but I have put here 65 to 70 which is already extremely bad. Okay. No choice at the moment, if you are able to measure 65-70 microgram per meter cube, you are already okay. But if this number goes some 4 times higher, you can think that most dangerous pollution level. So, where is 10, where is 40 and what is the number I have put here? It sounds pretty ridiculous, but I would say that if you are able to at least monitor this value 65-70 microgram per meter cube up to this value accurately, then you are very good. So, this is not really, you do not have to regard this as the number that is very good for humans, it is not a good number for humans. What we are saying is this is the approximate range you want to measure very accurately, up to this value you want to measure very accurately. For instance, NO2 10 to 45 ppb is what it should be even less than that, okay. It should be around 10 20 ppb or so, but if you are able to maximum able to measure up to 200 ppb accurately, whichever sensor you choose, if it is doing that, it is a good job. So, kindly interpret this chart more from the sensor, the sensitivity, the range over which a sensor should be able to measure these values accurately, not so much from the fact that these are safe values for humans to live in. These are not really safe values for humans to live in, and as you can see it is a clear indicator is particulate matter 2.5. Indian standard says 40 microgram per meter cube, WHO standard says 10 microgram per meter cube. This is already the difference. Okay. So, I hope you are clear with the interpretation of this. For a similar chart can also be done for exhaust air quality. So, this is another problem that we have, and you are looking at sensors which can measure accurately NO2 nitrogen dioxide up to 600 ppm, nitric oxide up to about 1000 ppm, ozone should not be there at all, ammonia should be less than 600 parts per million, and you can see that particulate matter 2.5 you should be able to measure accurately up to about 30 milligram per meter cube. All this happening because of fuel burning inside the vehicle. It is all about fossil fuels, it is about petrol, petroleum products like petrol, diesel and so on, which essentially are contributing to these gases which are coming from the tailpipe. Okay. Again, absolutely unsafe for human breathing, but sensors you choose should essentially be able to cater to this range, and you should measure quite accurately up to these ranges. That is the real focus of these two charts.